A diatomic nitrogen gas at a pressure of 1 atm and volume of 8.2 times 10 to the power of -3 meter cube is heated from 300 Kelvin to 400 Kelvin. What is the amount of heat absorbed by the gas if A. the volume is unchanged and B. the pressure is unchanged? C. in which process is the amount of heat absorbed larger? Why? When the gas is heated, the state of the gas changes. The value of 1 atm, 8.2 times 10 to the power of -3 meter cube, and 300 K, these three values give us the state variable for the initial state of the nitrogen gas. So from these three values, we can find out the number of mole of the gas, which is equal to P1 V1 over RT1. The subscript 1 refers to the initial state of the gas. N is the number of mole. R is a gas constant. We substitute the value for the pressure, which is 1 atm. In Pascal, it is 1.01 times 10 to the power 5 Pascal. Volume, initial volume is 8.2 times 10 to the power of -3 meter cube. Initial temperature is 300 K and the gas constant is 8.31. So we will get the number of mole of the nitrogen gas is equal to 0.33 mole. This number of mole of the gas will not change when the gas is heated to 400 K. So now for the first case, we can find what is the heat absorbed by the gas if the volumes is unchanged. So we can use the Q equal to NCV delta T to find this quantity of heat. CV is the molar specific heat at the constant volume. That means volume is unchanged, means constant volume. And the delta T is a change of the temperature. Now we substitute the N as 0.33 mole. The number of mole CV for the diatomic gas is 5 over 2R. R is a gas constant. And the delta T is a final temperature minus the initial temperature, which is 400 minus 300. Then we will get the heat absorbed by the gas when its temperature changes to 300 to 400 at the constant volume is equal to 686 joule. For the second case, we want to find out what is the heat required to change the temperature of the gas from 300 K to 400 K without changing its pressure. So the formula to calculate this quantity of heat, Q, is equal to NCP delta T, where the Cp is the molar specific heat at constant pressure. Again, the number of mole N is 0.33. Cp is for the diatomic gas is 7 over 2R. R is a gas constant, and delta T again it is 100 Kelvin. So we'll get the answer for Q in this case is 960 joule. This is the heat required to change the temperature, increase the temperature of the gas from 300 to 400 without changing the pressure. For part C, the question asks, between these two processes, which one the gas will absorb more heat? From our result of the calculations, we know that the case B, the amount of heat absorbed by the gas is larger compared to the case A. To make the comparisons, please note that the delta T and delta T for these two cases, we set it the same, which is 100 Kelvin. That means 400 Kelvin minus 300 Kelvin, we got the delta T 100 Kelvin. That means for these two cases, the heat required to increase the temperature for 100 Kelvin is the same for these two cases. But Apart from that, for the case B, the gas need more energy, need to absorb more energy to do work to against the external pressure when it expands. In the case B, the pressure is unchanged, means that we must allow the gas to expand. When it expands, it will need energy to do work to against the external pressure. Means that this case, the heat will absorb more energy compared to the first case where the gas volumes is remain constant.